Hello dear students. In the previous video we have done what is the principal value branch of inverse trigonometric functions. This was done in video 1 and we have done that sine inverse, cosecant inverse and tan inverse. These three functions are friends. They stay together, they live together, they work together. Right? So the sine inverse, cosecant inverse and tan inverse, their principal value branch is between minus pi by 2 to pi by 2, and rest functions cos inverse, secant inverse and cot inverse, these three functions, their principal value branch lie between 0 to pi. There is some exception in secant inverse except pi by 2, right? In cot inverse it is open interval 0 to pi. This is all we have done in video 1, and I told you this principal value branch is very important to learn. Once you knew this principal value branch, this 90% of your chapter is done. These are the domains. Domains are the numerical values from -1 to 1, all real numbers minus 1 to 1 except -1 and 1. So these are the domains of inverse functions, which was the range of trigonometric functions, and here ranges are angles, right? This you have to keep it in mind. Moving on with the next topic, in the video 2 we have done principal value. Find the principal values of the following. This exercise we have done. Principal values, what are principal values? The value of inverse trigonometric function which lies in the range of principal branch. So it means whatever we have done, principal value branch, the value of inverse trigonometric function which lies in that range, that is known as principal value branch. And very well we have done this exercise also. And today we are going to start with the properties of inverse trigonometric functions. If you see your page number 42, this is your page number 42. Now we are going to do the topic 2.3, properties of inverse trigonometric functions. These are the properties of inverse trigonometric function. Sine inverse 1 upon x is equals to cosecant inverse x, cos inverse 1 upon x is equals to secant inverse x, and next page tan inverse 1 upon x is equals to cot inverse x. You have to learn these formulas, but the proofs of these formulas will not come in the paper. I have written one proof here how to remember this. Sine inverse 1 upon x is equals to cosecant inverse x. Let sine inverse 1 upon x is equals to theta. So sine will go there. Sine theta is equals to 1 upon x. Taking reciprocal, x is equals to 1 upon sine theta. We have taken reciprocal here, right? And now after taking reciprocal, 1 upon sine theta is equals to cosecant theta is equals to x. Take cos that side, so theta is equals to cosecant inverse x. It means what is theta earlier? That is sine inverse 1 upon x. So we have got sine inverse 1 upon x is equals to cosecant inverse x. This is how we are going to prove other properties also, right? It is not sine inverse 1 upon x is equals to cosecant inverse 1 upon x. Please keep it in mind. It is cosecant inverse x. And we are going to learn these properties. Moving on with the next property now. These are sine inverse minus of x is equals to minus sine inverse x, tan inverse of minus x is equals to minus tan inverse x, cosecant inverse 1 upon x is equals to minus cosecant inverse x. So if you see this, you will find that these three functions, sine, tan and cosecant, I told you these are friends, they stay together. And whenever the value minus x is there inside, so minus will come outside and it will be sine inverse x. These are the ranges, right? So you know these ranges, domain, what to put here. sine inverse of minus of x. This is domain, right? So the x lies is the domain. So keep it in mind, sine inverse, tan inverse and cosecant inverse are friends. They behave same. So whenever minus is inside, minus will come outside. Next is cosecant, cos inverse x minus x, secant inverse minus x, cot inverse minus x. If you come here, next property, third property, if you see this property, minus of x is inside, so it will be pi minus cos inverse x, pi minus secant inverse x, pi minus cot inverse x. So you have to keep it in mind. These again are three friends, cos, secant and cot. So whenever negative sign is inside, you will put it as pi minus cos inverse x. Why it is so? Because we knew that when we have done the quadrants, this is your first quadrant, this is your second quadrant, this is your third quadrant, this is your fourth quadrant. The range of sine, tan and cosecant inverse lie in the first and the fourth quadrant, means minus pi by 2 to pi by 2, right? So value will automatically come in between minus pi by 2 to pi by 2. And when you come for these three functions, cos, secant and cot, you know that their values lie between, yes, their value lie between first and the second quadrant. This is 0, this is pi, so it lies from 0 to pi, right? If you have angle, any angle like 3 pi by 2, this is lies in third quadrant, it is here only. So how will you convert into 0 to pi? It will be, you have to convert, so it will become pi minus cos inverse x. The range should lie between 0 to pi, so you have to keep in mind this way. Third property, fourth property is sine inverse x plus cos inverse x is equals to pi by 2. Tan inverse x plus cot inverse x is equals to pi by 2. Cosecant inverse x plus secant inverse x is equals to pi by 2. These are the three properties. You know that sine square theta plus cos square theta is equals to 1, right? 1 plus tan square theta is equals to secant square theta. 1 plus cot square theta is equals to cosecant square theta. You have done it in 10th class. So here you will learn, if the inverse is there, sine inverse x plus cos inverse x, the value is pi by 2. Tan inverse, its reciprocal cot inverse, value is pi by 2. Cosecant inverse x plus secant inverse x, its value is pi by 2. So keep these formulas in mind. Hurriedly we'll be starting with the formulas now. Moving on, now see these formulas which we have done in class plus 1. These are triple angle formula. It means why it is triple angle formula? When it is sine 3a, cos 3a, tan 3a, cot 3a. So you have to keep it in mind. Sine 3a is equals to 3 sine a minus 4 sine cube a. I again remind you, when you have to go with the inverse trigonometric functions, the formula of trigonometric functions which we have done in class plus 1 are very important, very important. If you don't know trigonometric formulas, you cannot be able to solve inverse trigonometric functions. So you have to revise those formulas again and again, and you have to write these formulas in your fair copies also. Sine 3a is equals to 3 sine a minus 4 sine cube a. Cos 3a is equals to 4 cos cube a minus 3 cos a. Tan 3a is equals to 3 tan a minus tan cube a upon 1 minus 3 tan square a, and so on. Next formulas are double angle formulas and half angle formulas. Sine 2 theta, you know very well, 2 sine theta cos theta. Why these are known as double angle formulas? Because you have converted single to double, right? So, or you have to convert 2 theta into theta, or we have sine theta is equals to, we can write it as 2 sine theta by 2 cos theta by 2. It means this angle is whatever this angle will become half of it, right? Cos 2 theta, we have 3 to 4 formulas of cos 2 theta, that is cos square theta minus sine square theta. If you put this sine square theta as 1 minus cos square theta, so what you will get? 2 cos square theta minus 1. So you can convert this cos 2 theta in terms of cos square theta, or cos square theta minus sine square theta, or 1 minus sine square theta. 1 minus 2 sine square theta. The next formula is very important. This is tan through theta, and this formula we will be using it many of the times. Tan 2 theta is equals to 2 tan theta upon 1 minus tan square theta. If you have something like, let me rub this, if you have something like 2x upon 1 minus x square, you have tan inverse, right? I am giving you one example. You have this type of function. So you know that if you knew this 2 tan theta upon 1 minus tan square theta, once you put this x as tan theta, once you put this x as tan theta, this function will become tan 2 theta, right? And outside there is tan inverse, right? So this will become 2 theta, right? So in this way you are going to solve it. So whatever is inside, you should know what you will be putting it as, so that you can get it as an easiest function. If outside there is tan inverse, you have to make this function in terms of tan. Please keep this thing in mind. This is the hint. That's why trigonometric formulas plays a very important role. You have to learn these formulas. I am repeating it again and again. Moving on with the half angle formula now. In half angle formula, you will see sine square theta, very important again. Sine square theta, that is equals to 1 minus cos 2 theta by 2, right? So cos square theta, this you have to learn. Cos square theta is equals to 1 plus cos 2 theta by 2, right? Tan, these two formulas are very important, which you have to learn. Sine square theta is equals to 1 minus cos 2 theta by 2. Whenever there is a negative sign, so you will convert it into sine square. Whenever there is a positive sign, you will convert it into cos square. I am taking trigonometric functions again here because we have to solve the exercise in which we are going to use these formulas. So I have taken these formulas from the class +1, right? So make sure you have to learn these formulas before starting with the exercise. Moving on with the next page now. Next page, property 5, very important. Tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. Make sure what is important here, this thing is important. Xy is less than 1. I'll give you a hint. Suppose you have to find the value of tan inverse 2 by 3 plus tan inverse 4 by 5. Here this is tan inverse x plus tan inverse y, right? This formula is applicable only if xy is less than 1. So what is x here? X here is 2 by 3. What is y here? That is 4 by 5. So you will solve 2 by 3 into 4 by 5, that is equals to 8 by 15, right? 8 by 15, which is less than 1 because numerator is smaller than denominator, right? So once this property is solved, this property is done, then you can apply this formula, that is tan inverse x plus y upon 1 minus xy. I hope you are cleared with this property. So here tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. See here it is plus, so upper side in numerator plus will come. Here it is minus, in upper side numerator minus will come. If plus has come in the numerator, the denominator becomes negative. If negative has come in the numerator, then in denominator it will become positive. So what is the condition? Xy here is greater than minus 1, right? So you have to learn these properties. Again and again I am saying these formulas to revise it. Now what is this? Tan inverse x, 2 tan inverse x is equals to tan inverse 2x upon 1 minus x square. Modulus of x is less than 1. So what does this mean? X is less than 1, greater than minus 1. The value of x lies between minus 1 to 1, open interval, right? So any of these can come. So these formulas are very important. 2 tan inverse x is equals to tan inverse 2x upon 1 minus x square. Before starting with the exercise, learn this formula, write it 2 times in your fair notebook so that it can be easily understood. Moving on with the next property, that is property number 6. In fifth property also we have done 2 tan inverse x is equals to tan inverse 2x upon 1 minus x square. We have done this formula. So any of this you can revise. How this is all formulas related to 2 tan inverse x, right? If you want to convert it into sine inverse, if you want to convert it into cos inverse, if you want to convert it into tan inverse, then you need to revise these formulas. It's very easy. Tan inverse is perpendicular upon base. Just you have to learn only one formula, right? Suppose you have learned this formula, sine inverse 2x upon 1 plus x square. So this becomes your sine inverse, it is sine inverse, this becomes your perpendicular. Let me write it with another pen. This becomes your perpendicular, this becomes your hypotenuse, right? So now this is perpendicular upon hypotenuse. You can do it in this way. This is your perpendicular, this is your hypotenuse. You can find base. So what will be the base? Base will come 1 minus x square, right? So if you have to convert it into cos inverse, that is base upon hypotenuse. So what is base? 1 minus x square. What is hypotenuse? 1 plus x square, right? You have applied here Pythagoras theorem. So tan inverse x is perpendicular upon base. This is perpendicular upon base. Perpendicular is 2x and base is 1 minus x square. In this way you can learn. Just learn only one formula. Other formulas are very easy to learn. So learn this formula. 2 tan inverse x is equals to sine inverse 2x upon 1 plus x square. In sine inverse there is a plus sign, right? In cos inverse there is a plus sign in the again denominator, right? Perpendicular, this is perpendicular, this is hypotenuse, this is base, hypotenuse, perpendicular, base. So I hope these formulas are very clear. So after solving and learning these formulas, you are going to start with the exercise 2.2.